Good morning, everyone. My name is Andres Ondo. I am from Polytechnic University of Valencia. Today, I will talk about designing microcredential in power and energy engineering. The emphasis is important. The framework has not yet been implemented, so today I will not show learning results. Instead, I will explain the educational problem, the proposed architecture, and the evidence that a future pilot should generate before we make claims about impact. Power and energy engineering is changing in three connected ways. Decarbonization introduces renewables, storage, and electrification. Digitalization changes how systems are modeled and operated. Decentralization brings active consumers, distributed resources, and flexibility markets. The result is not only new technologies, but new combination of competence across networks, markets, and data. The degree program must preserve strong foundation, yet complete curriculum revision cannot follow every emerging need. The challenge is therefore to respond faster without overloading or fragmenting the degree. We position microcredential as a complement for bounded, changing application, not as a replacement for engineering education. Our framework is an iterative five-stage cycle. First, we diagnose competence needs from job roles, professional tasks, learner gaps, and several industry choices. Second, each need is translated into only 2 to 4 measurable outcomes and matched to workload and assessment evidence. Third, instructor and industry advisor co-design realistic cases while the university retains academic control. Fourth, delivery combines guided online preparation and an intensive workshop and an authentic challenge. Finally, learning, feasibility, transfer, and relevance are evaluated. The evidence supports an annual decision to retain, revise, suspend, or retire the unit. This traceability is the core design principle. The framework is illustrated through 3 units. Distribution network modeling asks learner to build and validate a feeder model. Energy market for engineers requires a settlement calculation and a defended bidding decision. Renewable integration asks learner to assess hosting constraint and justify a mitigation option. Each unit has independent value, but together they can form a 7 pathway in active distribution system after a cross-unit integration challenge. The assessment is deliberately authentic. An attendance certificate or multiple choice quiz is not enough. Learners must produce observable engineering evidence, explain assumption, interpret uncertainty, and communicate a defensible recommendation. Because implementation has not started, the paper proposes a staged evaluation rather than early findings. Phase 0 validates the need and prototype with advisors and prospective learners. Phase 1 pilots a single unit with a limited mixed cohort and uses the evidence to revise it Phase 2, test the remaining units and the stack. Evaluation covers 4 dimensions: demonstrated learning, operational feasibility, learner experience and inclusion, and continuing industry relevance. Importantly, claims are released in stages. The first pilot can support statements about feasibility and cost performance, workplace transfer needs, follow-up evidence, and employability claims require longer observation. Marketing must not move ahead of the evidence. The main conclusion is that short duration does not create value by itself. Credibility comes from traceability, and evidence competence need leads to measurable outcomes, aligned learning activities, authentic assessment, a transparent and verifiable record, and periodic review. This allows university to respond to fast changing energy practice while preserving academic quality. It also keeps our claims proportionate. The, the present contribution is a transferable blueprint, not evidence of impact. The immediate next step is therefore focus on an unrealistic, validate the priority need with multiple stakeholders, and pilot one prototype unit before expanding the portfolio. Thank you. Thank you for your attention.